Thank you very much. I hope you all had a nice evening so far. So I thought of giving you some insight onto the sensors, how to get the most out of the sensors. Right. Now, when it comes to IoT solution, we would look for certain objectives. So one would be it should save us work. It should save some of our day-to-day work, and it should save time, right? And I mean, for instance, say if I am traveling in a traffic in a road where it is headed to some traffic jam, and it would indicate me that it's a traffic jam ahead, so then I can divert. So it will save some time, and it should improve our communication, that we will know details first, so then it will improve our communication, and it will bring some valuable insight. I mean, some information that we couldn't catch before could be identified when we have IoT infrastructure. I mean, when you have a network of IoT solutions, that you would get very valuable information out from that, from analytics or whatever you call it, and then it will be very useful for you to make some decisions. So it is there to bring us some valuable insight, and it will save natural resources. We know that there are some energy saving devices that built into IoT systems would save our natural resources. So having said that, we have all these expectations in our hand, and now how do we go about achieving this? So you won't believe that we are going to plant around 20 billion devices around us. So imagine we have a huge number of devices around us. So it's more or less our city would be so busy, with a lot of communication happening. Now, I have one question in my mind. What would happen if these devices bring invalid inputs and our IoT infrastructure take those invalid inputs as valid? What do you think? What would happen? Right? It would make disasters, right? So it would even be a crash. So this very important thing we need to think about as IoTers. We have a huge responsibility in handling this. So we need to know how the sensors or devices that we place in an environment where it would not make this mistake. So this is what I am going to talk about today. Now let's start with an example. So most of you may all know the Colombo IoT project we have started along with this Colombo IoT meetup group. So we had a lot of challenges in that. So basically, Colombo IoT project is all about that we save some of the animals in a drought situation in the middle of jungle by filling some of the tanks inside. So we had mainly two major difficulties. One is communication, and one other thing is power, and the other one would be that environment conditions. You have dynamic environment conditions out there, so you need to manage that, and of course you cannot reach there all the time, right? So we should be able to remotely see all this what's going on. So from the communication perspective, so we get a lot of standards, like we can connect devices using wires. So that's one of the standards we follow, right? Most reliable would be. And we have RF solutions, radio frequency we use to communicate between devices. So of course wire is not possible, right? Even though it's a standard, it's not possible in a jungle. But even though we have RF signals, again we need to have some strong signals because it's middle of the jungle where sensors located in far different places. As you can see, it's far away sometimes. So, and major difficulty we were facing is that how to get those details out to some control system far away, maybe 10 kilometers away. So apparently we didn't have signal, telecom signal strength there, so we cannot even communicate. So these are the difficulties this project faced. And the other thing was that different environment conditions, it could be high temperature, it could be very wet conditions. So whatever the device we place there should be capable of to react those environment conditions and should generate valid outputs, right? Valid outputs, very important. So that's the way that we can assure that whatever the readings that we get is valid. Now the point here is that we cannot reach the place all the time, right? So it should work for years. When we plant those devices, we cannot go and see all the time. So it should work for years. So environment conditions, whatever we have now, would not be there in 2-3 years, right? So those are the factors. So I took that as an example how difficult that would be, that when we are planning IoT solution in a practical situation. So let's see what is mainly governing this particular problem. That is environment, right? Environment is the key. So where we plan our sensors, where we plan our devices, what would be the conditions are, how long it should run, how about when you have battery powered solutions, how far it would operate. So these are very important things that we need to consider. Now we will look at how, now we know that there are objectives that we need to achieve, and there are different conditions in the environment that we need to face for. Now we need to find out a way of finding out what's the best suitable device or sensor that we could use for these different environment factors that would suit for. So let's look at some of the characteristics that you would get in sensors that we need to look for to see whether our requirements are fitting to those characteristics. So that's what we are looking for, right? We're looking for characteristics of certain devices and sensors, and to see whether the requirements we have to cater these environment conditions, whether those are fit into those characteristics. So we will have a look on some of these most important things maybe. The first one to go about is transfer function. So when you get a device, you have a physical signal. I'm measuring temperature maybe. So that's my physical signal. And I'm converting that to electrical signal, and I'm going to measure that. So there's a transfer function. Transfer that physical signal to some electrical signal. So this is very important, where transfer function is valid for certain range. Now, for instance, in this case, this is it's linear only up to this, but after that it is non-linear. So we need to consider that. We need to see whether our requirements falls into this characteristic, whether my range of environment condition falls only within this range. So that is very important factor we need to consider when we go for a sensor. And the other thing would be sensitivity. As you can see, if you take a thermometer, that if it is measured by 2 centigrade by 2 centigrades, so of course you cannot measure 1 centigrade change. But if you have a sensitive thermometer, you can even sense 1 centigrade. That's the condition of B here. Right. Now, how do you know these figures? How do you identify these figures from a sensor? There's something called data sheet. So each and every device comply with a data sheet. So you should be able to get these details down from the data sheet. Now, for instance, in this case, the sensitivity is given here. So this is an accelerometer data sheet. So you could find sensitivity there. So likewise, you need to look for the data sheet and find out what the characteristics values are. Right. The next factor is span or dynamic range. So this talks about the range the sensor is valid. right? Input range it would work for. Now in this case, the example that I took, accelerometer, is having the measurement range is -50 to +50 of gravity. Now that is the range. If you go beyond that, if you think that your requirement is beyond that, this is not the right device for you. So it's important to see whether span is within your requirements. So next one is accuracy. Now when it comes to accuracy, it depends on certain factors. Now it decided by the temperature. Now for instance, if you place your sensor exposed to direct sunlight, of course the temperature would increase. So we'll have to see whether those temperature increases would affect our readings or not. So there are graphs. So you can see, looking at the data sheet, you can see those ranges. And similarly, you can have pressure, humidity, and all those factors. And especially the supplied voltage. Now, for instance, if your sensor is battery powered, you need to know whether how long this would work. So when battery power reduces, how would this react? What's the range? So it should work for low battery power as well. So that's one of the things that we need to consider. So, and it should indicate whether low battery or not. So those are the very important things that we need to consider. And the equipment tolerance. So this is something important that we need to know, where a sensor is made of some small components. Now those components would have its own tolerance. So for example, if you take resistors having different tolerances, maybe 20% sometimes, or maybe 0.1%. So 20% tolerance is if you take 1000 ohm resistor, when you manufacture it would be sometimes 800 ohms or maybe 1200 ohms, because 20% tolerance is there. So if you take 0.1%, it's very less, but it would be expensive. Now in fact, I have experienced that some humidity and temperature control sensors could be buy in some thousands here in Sri Lanka. At the same time, some better sensors are available for 40,000, right? So you could see huge difference. Why is it that all these qualities are different from sensor to sensor? So when you take a device, we need to look for all these graphs and all these values, all these characteristics to see whether what sensor is suitable for us. So when it comes to tolerance, there's one way to overcome that. That is individual calibrated devices. So this is again expensive. I mean when you manufacture a device, generally those are manufactured in production lines, right? So you don't manufacture one by one. I mean those are in production lines. So, but in the case of individually calibrate the device, then we could basically cover up this tolerance issue in a greater extent. So you could buy the individual calibrated devices as well, if at all you need to. Alright, so the next characteristic would be hypothesis. So this talks about when value physical value increase from one value to the other and it decrease back, it follows two different graphs. I mean, for instance, this P1 value give when it increases one value and when it decreases another value. So there's a gap between these two. So we never know when you read sensor value whether it was increasing and it was decreasing, right? So we need to know this difference. In fact, I couldn't find this characteristics in the data sheet that I referred here. So these are the things, right? Then we need to find out those from the manufacturer, if it is so important for you. Right. Next would be non-linearity. So even though we talk about this linear curve, but it's not the case practically. So for instance, luckily this particular sensor, they talk about non-linearity here. So it says 0.2%. So there could be 0.2% variation. So you need to see whether you could manage with 0.2% variation in implanting this sensor for your IoT solution. Right. So similarly, there are some other characteristics like bandwidth. Bandwidth talks about the frequency, acceptable frequency of your sensor. For instance, if you take a temperature sensor, temperatures change continuously. So our sensor would be capable of capturing certain values, values in certain speed, right? The maximum speed it would capture is the maximum frequency, and there could be minimum frequency as well. So gap between those two is bandwidth. So we need to see whether the value that we are going to capture would fit into the speed it works, would fit into this particular bandwidth. So that's also again important factor. Most importantly, noise. Now, when you read a value from a sensor, as I said before, the question we had was whether those values are valid, right? If it includes noise, and if we take noise as a valid input, valid output from sensor, so we are nowhere, right? So we need to know this factor very well. So what's the noise ratio that we are talking about here? Mostly it is relevant to the frequency of the measurements. So then you can calculate the noise level that you would expect from the range that you are looking for. And the resolution. Resolution gives the minimum value that you could read out from a sensor. So of course, minimum value you could read depends on the noise and the sensitivity, right? How sensitive your device is, and at the same time, what's the noise containing that device. So the minimum value could be decided by that. That also could be calculated. So now we have some knowledge of what the characteristics we have with the sensors, and if we know the environment condition that we have and those requirements, and we can of course match these characteristics along with those requirements to see whether this device is suitable for us or not. Right. Now all these could be taken from the datasheet that we talked about, so-called datasheet. But it is unfortunate to say that datasheets are generally marketing documents. I mean, when I get a request, look here Thejaka, why don't you make a sensor for us? Right? So then I will make a sensor to satisfy the customer. Right? That's the business. But I don't stop my business by that. But I just put my sensor to the market. I put up a data sheet which includes the customer requirements, and I put that to the market. So we go there, we say, alright, this is cheap, I should buy this. So we buy that. So that doesn't mean that it covers all the characteristics we want, right? So we saw one example just before. Now, so even though it is the case, we should be able to find the details from the supplier, right? We could always query the supplier and get the details down. So what I want to make you aware that as IoTers, we need to know these things and find out the details we want. Right. When you look at the whole system as it is, you could see that we sense the physical variable from the sensor, and then we convert that to digital values. Why we convert it to digital values is that, so digital value is useful, mainly needed for us to take decisions. Right? Once we take the decisions in the digital system, we convert them back to analog signal. Example is that if I want to close the door when the session starts, right? I will from a sensor will detect that session started, and then we'll process that data, and then we'll have a motor to drive that to close the door, right? So to drive a motor, we need to increase the voltage. So according to the digital signal we have, we need to drive a physical, analog signal, which is voltage. So then it will the motor will drive and close the door. So similarly, we have controllers for analog to digital converters and digital to analog converters. So now this is again one important thing we need to know. So when you take a temperature sensor, you read the digital value, right? You read if you plug the sensor to your computer system, you read the digital value. So we'll see how this conversion happens. Now, if you consider the resolution of this conversion, if you take a sinusoid signal like this is a physical signal I'm talking about. if I have 1 bit to represent digitally, so you could say when it up, it's 1. So likewise, if you take 2 bit, 3 bit, 4 bit, 5 bit, you could see the resolution is high. So this is very important to know that how many bits does it use to convert these physical signals to digital signals. That's also something you need to find out when you get a sensor and when you connect it to your system. The other thing is signal analysis. Now, if you take this example, you see that my physical signals varies like this. But the sampling that you do, I mean the samples I take out from this physical signal is these points, right? But apparently what I have covered, what I have got is a completely different signal. So right, so this gives very invalid output for us, which is totally wrong. Now how to go about that, how to correct this is that our sampling rate should be at least twice of the signal frequency. So those are important things that we need to consider. Now we looked at certain characteristics and we looked at certain behaviors and we looked at how we find those details from data sheets, and of course sometimes we need to contact supply. And we know what the objectives that we are going to achieve, and we know the environment conditions will differ from project to project. So we know we have now requirements and we know the characteristics. Now we need to find out the best sensor matching those characteristics and requirements. Of course, that's all today I'm going to talk about. So making you aware of those characteristics and how do you compare that with the physical variables. Right. So it's a quiz time. So I have 2 questions. And the organizers have prizes for them. So I have 2 questions. If you're ready to answer. All right. So first question is, name 2 essential sensor characteristics. So I talked about this very easy one, I guess. See if you could name 2 essential sensor characteristics that we talked about. Sensitivity, yeah. Yeah. Okay. He came up with both straight away before the second one, so the prize goes to him. Great. Thank you very much. And the second question, name 1 major characteristic we need to consider in an ADC, I mean this analog to digital conversion. Name 1 major characteristic that we need to consider in analog to digital conversion.
Resolution?
Okay. Yeah, great. So thank you very much for being with me, and I hope you got some insight into this.